Seems like this doesn't really work. Usually when a speaker stands on a stage and does this, you also do this, because then the people around you see you're holding your hand up and they're wondering what's going on, and they stop talking. Stop talking. So, hello, welcome. My name is Diana. You probably saw my face already on Meetup. I am the conference and community manager of GOTO Berlin, GOTO Conference, GOTO Berlin, which is a conference that is only once a year. Who has no idea what GOTO Berlin is? One, two. Okay, it's an IT conference with several tracks, concurrent tracks. And since it's just once a year, we don't want you to forget us, right? So we have this awesome GOTO Nights where we have awesome speakers like Christian, who can tell us something about the newest technologies and how they do something. And you can learn from them. So this is why we're here tonight. Just some little things. We have drinks over there. We have food over there. Restrooms are on the left and right-hand side, depending on where you want to go. Smoking just outside, talk is here, slides are up there. You can win a ticket to go to Berlin, awesome conference by the way, in November 14th to 16th. Over there, just write your name and your email address on one of these green little sheets of paper and put it into the box. We will draw the winner after the talk. When you write your name on it, try to write it like really, like I can read it. Not like a doctor. That would be great, thank you. Did I forget something? No? No, I think that's it. So thank you very much for taking the time for tonight being here. And please welcome with me Christian, who will tell you some stories about how to get your microservices into the cloud.
Thank you for the introduction. So welcome to GOTO Nights and how AutoScout is building microservices in the cloud. Who is doing microservices from of you? Okay, about a third. Who is already in the cloud? Okay, also about a third. Who is in AWS and specifically? Who is not in, he was in the cloud and not on AWS. Ah, cool. Okay, so this is why we came up, by the way, with one of our principles loosely coupled, so that we are not dragged along all the time. And this is how it feels working at AutoScout, by the way. So I'm Christian, I'm an architect at AutoScout, and I'm with the Tatsu project, which I will be talking about from the beginning. I'm with AutoScout for now 5.5 years, and currently in the role as an architect. I assume you all know what AutoScout is doing. Who doesn't know what AutoScout is doing? Okay, so listings business similar to Immobilien Scout, just not for flats, just for vehicles, 2.4 million of those on the platform. We are in 17 countries, have about 350 employees, 120 or 40 around in IT. And this is how currently and previous times our cache stack, as we call it, looked like. So we had massive data centers and still are running them. We are running on a Microsoft ASP.NET stack. Who's running .NET? Who's a .NET guy? Wow, 3 of you. So, so this might be particularly interesting for you. So Windows, .NET, Oracle database, everything is virtualized using VMware. We had about 2,000 of those servers in our VMware running in 2 data centers for disaster recovery. And the whole setup was optimized for mean time between failure, meaning big expensive hardware, everything is redundant, every box has 2 power supplies. And from a software engineering perspective, we just assumed this stuff will never break. And the operations guy made sure that it never breaks by paying extra for money for that. Besides that, we already had proven agile and lean principles, and the whole setup was capable of supporting all the needs of IT. But within the company, there were, at that point in time, about 2 years ago, already some cells that were whispering cloud or infrastructure as code and things like that. But there was, from the operation side of things, there was an inertia against this. And this reminds me of this picture. So we want to go where the rest of the world is and don't want to be dragged into the enterprise IT setup. So this is for specifically true for cloud. So we had the feeling we are losing out, we need to go there soon. But it didn't happen. Everything was stable and we were making money off of it. So no need to change, we believed. And then at the end of 2013, the whole Scout group was sold to private investors. And soon after that, a new CEO came on board and he asked us a question about our stack. Are you ready for the future? Is your Windows.NET stack actually what you want to have in the future? And one of the more important questions he asked was, do you attract talent? Is this something, is this the IT setup you have, is this actually attracting talents? And up until that point, we believe we are great. But looking into the talent aspect, we learned that there are technologies and there is excitement and there is community and there is talent in the .NET ecosystem. So we are all the engineers from AutoScout have a .NET background, and this ecosystem worked for us, and this flywheel actually is still working. But when we then compared this to what's going on in the JVM ecosystem, the flywheel was bigger, the flywheel was turning faster, and almost all of the interesting things are at least available for JVM based when not actually based on JVM things. And we also learned that especially in Munich, a lot of the .NET developers we were able to hire were good .NET developers, but they weren't familiar with the web and with the internet. In Munich, there are insurances, banks, and a lot of the .NET developers are coming from those companies, and we need to teach them how to actually do web development. And we believed we can change this. So our notion was, we are good, we are not great, and we need to change something. And when we want to change something, we believed, okay, then actually let's change everything, not a single piece in there. And this is how Project Tatsu came to life. And the roller coaster you have seen in the beginning, before the talk started, the roller coaster is named Tatsu and is in California, Six Flags Magic Mountain. And this is how this project feels like. It's also a Japanese dragon. And our project Tatsu started in the end of November 2014. And we aimed to actually change a lot of things. We wanted to move from .NET Windows to the JVM Linux stack, mainly. So we wanted, I already explained why we wanted to move from C# to the JVM, but even more important was to get rid of Windows, which is not something you want to be on if you want to heavily automate your infrastructure. So therefore we needed to switch to Linux. Along the way, we wanted to also rewrite everything that was currently part of our monoliths into microservices. And of course, when we tackled that one, we wanted to get rid of our data center and move to the cloud, specifically to AWS. And we also have the heritage that we had an operation and a software engineering department, and those two silos were cooperating at that point in time. We had some DevOps and communication going forward, but this were still separate departments, and we wanted to move to a more collaboration or DevOps culture where we actually embed the operations guys into the teams. And of course, when we rewrite the core parts of our application, we also wanted to take the chance to involve the product people so that they have now the opportunity, what we called at that point in time, to make a shiny new cut, to cut out everything which was craft from old times, and to actually make this is not only a technical transformation where we just rebuild everything we have in the new stack, but also along the way try to rethink our product. This is how we envisioned our technical transformation. So we already had in our data center the monoliths and some swim lanes. Those swim lanes were still coupled via the same database and were not intended to be proper services like in SOA or in microservices, but they were mainly carved out to give us better continuous delivery capabilities around those swim lanes, because it took quite some time to release the monoliths, and the swim lanes could be released faster. And our technical transition then should involve that we carve out a vertical slice out of our monoliths or out of those swim lanes and rebuild this vertical slice as a microservice, or if you know the term, self-contained system. So the important part for us, this needs to be around a capability. This shouldn't be carving out a horizontal slice, pulling out the data layer or the front end, but we wanted to cut along business capabilities or a bounded context. And the important part for us in there is that the decision how big the services is actually not important, and that currently in our migration path from our swim lanes, which were still coupled to self-contained systems, these are a little bit bigger than what you typically would see in a Netflix-style microservices architecture. And this, I always call it, so now it's called self-contained systems. Before the name, I just called it Stefan Tilkoff architecture. So this is to make the difference. And those services are also end-to-end services. So they're rendering their own UI. These are not API services or back-end services. One of those services should be responsible to also render the UI. When we started in end of November, we created one team. We also pulled in external help. So 4 guys from AutoScout who were eager to try this new approach, and for consultants formed the first team. And at that point in time, we were thinking about how to approach this for quite some time. So we were very tightly aligned. Everybody was thinking the same. We didn't need to actually argue about stuff. But when we then ramped up to about 4 teams, half a year later, we recognized that some of the things we initially believed there's no other way to do it, this is our principle, was no longer true, because they actually could not know it, because they weren't part of the initial bootstrapping phase. So we came up with our principles. This is the idea behind this is that we still want to go into the same direction, but when you're talking about 4 teams, and now we are more in the realms of 12 or 13 teams, you need to align along those principles. And all those principles up there, the middle column is the architecture principles on the left, or from the left. You see the strategic goals, which are important for us, and the principles and the practices should support those strategic goals. The most important thing for us is time to market, or to put it easier, to be fast and to have fast feedback. So speed is the most important thing for us. And this is why we want to support the business to actually come up with new ideas, and we will be able to support them. Of course, data-driven, nowadays you need to be data-driven. It's also one of our strategic goals. And when moving from data center to the cloud, cost is always an issue. So therefore, we also have the strategic goal of being cost efficient. All the architectural principles up there should support it. I won't go into details now. We will touch many of those during the rest of the talk. Important for me around this principle slide is these are our principles. We came up with those principles during discussions, and we have written them up. Some of them we just borrowed from other principles, but in essence, these are our principles. This is a very valuable tool for discussion and aligning, and actually have a proper discussion also around feedback to those principles. So I would I would strongly suggest you to pick something up like that, but don't just copy our principles, because your principles need to fit your architecture, your culture, and your goals. Do we have any questions for those principles? Okay. So I will dive into some of those topics we have on those principles. And two of our principles together are autonomous teams organized around business capabilities. Business capabilities, or bounded contexts, is what is very good explained in the blue book from Eric Evans. So this is around domain-driven design, or actually finding your buckets of capabilities and actually separate your architecture around those, and have autonomous teams. And autonomous teams therefore means that those teams are responsible for what features they are building, and they should build products and not projects, and should not work in a collective code ownership way, but have their own repositories, their own services for which they are responsible to build within their business capabilities. And this is very important for us, which was already hinted at when we had our monoliths and split it up into those swim lanes, that this is a very useful approach for us to actually scale the organization. When we had our monoliths, when we reached about 14, 20 developers working on the same code base, things were getting ugly. And if you now have those more autonomous teams responsible for their own services, you can scale your organization way better. And within those autonomous teams, we also have the collaboration culture, meaning that we were shifting away from the two silos of operations and software development, and put the operations guys actually into our cross-functional teams. And in the beginning, for many people, this felt very awkward, but from our initial teams, we embedded two of those operation guys into the team, and this was very successful, and people liked it, and they actually talked about it, and in this way, the rest of the organization actually learned that this makes sense. And why are we very keen on this collaboration culture? For me, this is the true sense of DevOps. DevOps is for us no longer a tool or a role or a team. DevOps is devs and ops actually working together, and working together in the same team, sharing the same goal for their services. And what we then learned is that this was a really good thing, and we started to actually change our name for us. And so we said, we are all engineers now. No longer we're talking or try to talk about, this is a software developer and this is an operations guy. We are now all engineers. But besides the fun in the Seifenkiste, you still need to look out what's happening in the teams. So what we found out, when you have a team of 4 prior software developers and 2 ops guys, even if you call them engineers and have them all in the same team, bad things can happen. For example, very visible, the 4 software developers are sitting on the right side, and the prior ops guys are sitting on the left side and doing the ops things, and the other are doing their application development, and they just happen to be in the same team. So you need to make sure that actually pairing, and they're working on the infrastructure stories together, and actually also the ops guys are working along the application, so to make this actually work. Of course, all in the long run, we still believe that not all T-shapes are the same, and not everyone in this team needs to know everything. There will still be experts, but as the team as a whole needs to be able to do everything that's needed to support the team. And this leads us then to another very important thing. Those teams that are now cross-functional and autonomous are also responsible for running their services. So no longer is a handover to the ops guys, I write code however I like it, and then somebody else has to run it with all the bad things that could happen. So if I write bad code and the ops guys then are on call for my bad code, then the feedback, as we have seen on the initial principle slide, does not come back to me. I need to be woken up if I write a shitty service, and therefore I will then later on improve that I write code that does not wake me up over the weekend. And what in essence this means, with the freedom of being an autonomous team and having the capability to run the services, also comes the responsibility to actually make sure that those services are running. The you build it, you run it meme is then not also is not limited to the operational side of things. We are not quite there, but we also believe that those teams should be should be responsible to also listen to the consumer and thinking about what actually the next iteration of the features in the service should be. And yeah. So, so people can't completely strip off their heritage, and I know them from prior ties. So we call them engineers, and typically the engineers will, the former ops guy will do more ops work than the software guys, and the other way around. But the lines are blurred, and the collaboration is within the team. So you still can tell this guy has more knowledge around system administration, and perhaps the other guy has more knowledge around proper clean code application development. But we also have seen things like that a former software developer is now more interested in infrastructure and is doing more and when talking to our infrastructure guys and telling them, lucky you have to know we are building a service for feature toggles now in one of our more infrastructure related parts, they are looking forward and say, yeah, I can code now, this is beautiful. So you have both sides, and of course you have people in there who are, especially when they are coming from the Windows administration side, they are not so familiar with all the scripting and the automation and the coding part. They have a more difficult journey ahead of them, but overall it works out quite well. And if you would not know, when you look at those teams, nowadays I believe it would not be easy to pick out who used to be an ops guy and who used to be a software developer. Okay, so this we have. Continuous delivery. Of course, with all the improvements around the team setup, we also wanted to improve around continuous delivery. At AutoScout, when I joined AutoScout, our monolith was released once a month with a 1 week of lockout before that, where we were merging stuff, and then we released the monolith. And we improved our capabilities to continuous delivery very, very strongly. And nowadays we can have daily release of our monoliths and hourly release potentially of our swim lanes. But we are within our cache stack, our continuous delivery was limited to shipping code to already existing servers which were set up via VMware. So this was just continuous code delivery, but all the other parts of the infrastructure, all the other configuration was still handcrafted or partly automated. So we also wanted to improve on that, and this is one of the reasons why we actually changed everything at the same time. So it's way easier to configure, have an automated configuration of Linux than it is with Windows, but going to AWS levels your potential for automation up even more. So from our perspective, there are many good reasons to pick AWS. For example, you don't do the undifferentiated heavy lifting. They have a lot of high highly valued managed services from which you can participate. But after the initial thoughts about AWS, what's now the most important part for me for this kind of infrastructure is that it has an API, and from AutoScout perspectives, we are not Netflix. So from our perspective, the resources available to us are more or less unlimited. And having infrastructure as an API is a very powerful thing. And of course, that now infrastructure is a commodity. You just have to pay for it. There's nothing else to do. Yeah. Depends. So I just go back. There is one of our principles which actually says AWS first. So we made a conscious decision that we are not abstracting away the cloud and work only on compute and storage resources, which you could do, and then you could easily in quotes, move between one cloud or your data center to another cloud. But one of the advantages of AWS is that they're constantly improving and adding new services, which we can leverage so that the heavy lifting we need to do is less. So of course, this includes a vendor login. Yes. Yes, very briefly. 2 seconds, 3, no. So first of all, have you seen so I'm not a Gartner fan, but in this case, it helped arguing there's the Gartner Magic Quadrant of public cloud providers, and there are about, I don't know how many, but there is Google Compute, Azure, and DigitalOcean, all of them are on them. And the two axes were ability to execute and completeness of vision or something like that. And AWS was in the right upper quadrant, and only Microsoft at that point in time had managed to actually get into the upper right quadrant. And I still believe this is a fair assumption. Also, AWS is in itself 14 at that point in time was 14 times bigger than all other cloud providers together. So, and it has a very good track record of no outages or very few major outages, lots of APIs. So it was the most matured service, and we didn't have any Windows affinity anymore because we wanted to get rid of it. So therefore, Microsoft was also not the first choice. Nowadays, I would also look at the Google Cloud Engine, compute engine, because they are especially around data, are very interesting, but the grass is always greener in the other cloud, so therefore, for now, we stay on AWS. But yes, this is in the realms of, you can argue why you have picked it, but it was the biggest, the best track record, the most services available, the most experience. They made the best overall impression to us. Yes. So the question was why we have picked AWS over Azure. So, but yeah. Yeah. So the question is, okay, so the question was why we were actually moving away from Windows.NET and why we didn't make microservices and cloud within this ecosystem, which also would be possible. And if I look at the Microsoft ecosystem right now, the choice would have been harder. they improved by quite some measure. But at that point in time, if I look at what companies are actually the companies we are looking after, companies like Netflix, Amazon, yeah, Uber is not a good example for JVM, uh, LinkedIn, all of those companies, Immobilien Scout, so those companies which are the giants or the unicorns from which currently, at least in our industry, most of the innovations are coming from JVM-based companies. So at previous times, we were looking at Oracle for new innovation. We were looking at Microsoft for new innovation. We were looking at IBM for innovation. But nowadays, this is no longer true. The big vendors are actually not coming up with the new tools. Nowadays, you want to use Kafka, which is a JVM-based tool built at LinkedIn. You're looking up after Hystrix or other Netflix tools, which are mostly JVM-based. We tried to get Kafka running in our .NET world, and no .NET driver available, at least not at that point in time. The driver was available for all the, and you have a constant uphill struggle to get your stuff running with where the innovation is happening. That this is an uphill battle which we didn't like. And then of course Windows and automation and immutable servers and those things, this is not something you like. Of course. Yes, of course. So I believe now we would not easily switch away from Linux, besides eventually going to unikernels, but this is a different topic. We've picked the JVM, and to be more specific, within the JVM, we've picked Scala, and this is intentionally only a starting point for us. So we were very conscious about that. This is not set in stone, and we want to be now a Scala shop. This was a starting point. We needed to pick something where the initial teams were actually building stuff in, but if now our team would say our use case would be better solved in Golang, and we actually can be well-behaved citizens within our Macri architecture we currently have, then they would be allowed to do so. Yes, within boundaries, of course. So if we would then look back and have 10 different technologies within our company, this would not be maintainable. But what I strongly believe in is that we are paving the road with our Scala microservices. So now for teams who want to build a new service, it's way easier for them to pick up a service template and have all the infrastructure in place for the Scala service than rebuilding or adjusting the stuff for picking a different technology. So therefore, that most of the teams just follow what's already there. And if there are good enough reasons to go somewhere else, and very important for us, this shouldn't be a hype of the day decision. Somebody at Netflix told me, your freedom is not my responsibility. So if they pick something different, they need to be able to support it. They just can't run away. Oh, now I've got this Golang service, what to do about it? Yep.
You mentioned that you completely switched the platform, like from Windows to Linux, from .NET to JVM stack.
Yep.
But do you still got the same developers, or
Yes.
how they will?
So actually, we have not switched. So we are starting so we are in the middle of our journey of rewriting. So we all still have a lot of the old. So I'm not repeating the questions again. So bummer. So we are not. So the question was.
You switched the platform, but do you still have the old developers?
Yes. So we've switched the platform, but do we still have the old developers? Yes. And this was also by intention. We were those are good engineers, and for a C# developer, going to Scala is a step, but it's not impossible to do. And nobody has left from that perspective. But of course, you need to give them time. They won't be as fast in the beginning, sure.
How do you handle shared resources like databases, search engines, and
Okay? So the question is, what about shared services like databases, message buses, and stuff like that, and how the teams are actually isolated or separate. So each microservices, of course, has autonomy over its data, so there is no shared database at all. This would violate one of the core principles of doing microservices. Currently, we don't have a message bus, but we are currently rolling out Kafka for parts of our queuing or streaming needs, and those kinds of things. Then you come into muddy water where you actually begin to share some infrastructure, and of course we have shared infrastructure around monitoring, logging, and those kinds of things. But for what's needed for one service, there's no sharing at all. So message bus would be an exception because this would not work if it would not be shared. This would break the concept of messaging. But no shared databases or shared infrastructure. So one example, we have set up a dashboard service using dashing, which is a Ruby service. The first team did it to put up the first KPIs and the first states of our delivery pipeline. And the second team just put their dashboard into the same dashing service. So now the service has two URLs, the dashboard for team A and the dashboard for team B. A shared service. Nothing bad could happen. Don't believe that. So the teams put in one of their metrics was requests per second on the service. And the one team only had, per minute. One team only had 10 requests per minute and the other team had 4,000 requests per minute. And they were sitting next to each other. It took them 3 days to actually find out that they used the same global state within the service, and now they were seeing switches from 10 to 4,000 requests per second every 5 minutes, and were wondering what's going on. So this is a very good example that it's way better to not share those things. So now every team has just their own little Ruby services flying around, and on AWS you have those small instance types. Cost is negligible, but now they are completely isolated, and this is a good thing. Yep. So monitoring and logging are the exceptions. These are shared. So we have a central unified logging infrastructure, and all of our services are logging into the same infrastructure. Yeah. So you have some coupling, but the coupling is a different kind of coupling as you would use a shared database or something like that. So this is one of, yeah. So now we are diving deep into shared databases and microservices and how to actually deal with data in microservices. I believe this would break what we now want to talk about. In essence, you will replicate data to other services. This is the solution, and you won't have a shared database. But let's continue with the talk so that we actually hear a little bit more. But very interesting questions. I do like it. So where have I left off before I was delayed? AWS. So AWS sparked a lot of those discussions. So, and I was talking about how much I do like that the infrastructure is an API. And one of the things that is we are now capable of doing is to actually do proper infrastructure as code. We had the advantage that Keith Morris, who is now writing the book about this, was with the project for the first month or so. So every infrastructure we create in our AWS account is coming from a repository. For example, if we have a service where we have an application and some infrastructure configuration, this is in one repository, and we have one delivery pipeline that is actually delivering the infrastructure changes and the code changes. There's no difference whatsoever. So if I change a code, fix a bug, or introduce a new feature, it goes to the exact same pipeline, as I would say, for example, I change something in my auto-scaling group, or I fiddle around with the DynamoDB for this service, it's delivered exactly via the same delivery pipeline. So all our resources on AWS are coming from repositories and delivery pipelines, and hence the name infrastructure as code. This gives us a very good traceability and repeatability. We know actually how we would need to create our account or recreate our account. And this also gives us then the advantage of having that we are now capable to introduce some convention. So as every infrastructure is created via the delivery pipeline, we are actually now alerted if there is a change to our production environment that is not coming via the delivery pipeline. There is an AWS service, CloudTrail, where every API call is logged. And if there is an API call which is not triggered from our delivery pipeline, then we get an alert. An unexpected production change happened. And this way, you actually make sure that there is nobody fiddling around with your production environment, despite going through the delivery pipeline. Yes, of course. Yeah, so somebody, a new guy enters the project and sees, oh, the throughput on this DynamoDB is too low, I need to increase it. Of course, he goes into the console, increase the throughput, and then 60 people have an pager alert. He will not do that again. Another interesting thing we've picked up is immutable servers. This is also very easy to do with AWS. So every EC2 instance or every virtual machine we are creating there is recreated from scratch if we have a code change. So in our old environment in the data center where we did the static code deploys, of course some of those servers had a different configuration than the other. Some had an uptime of weeks, others days, were created at different points in time when we need to scale, and we didn't like that. So now every code change actually recreates the whole machine, and with the auto-scaling groups from AWS, this is rather easy to achieve. And pardon? No, we are not. So the question was, do we use Docker? No, we don't use Docker yet. We have some Docker flying around, but currently we are using the abstraction that each server is running one service. So one EC2 instance, one service, and we are using ELBs and auto-scaling groups for that, and it works quite fine for us. And Docker in production is still something we actually don't know what to choose. Swarm, Kubernetes, ECS, and which is the one that's winning, and currently our pain is not high enough. So we don't need the utilization, and we don't need the delivery cycle that's provided by Docker. But our delivery is very similar to what we would do if we would do a Docker-based deployment. Currently, our artifacts are zip files from our application. If the EC2 instance starts, the only thing it does, it downloads the zip file from S3, unpacks it, starts the shell script, and watch for the smoke test to be green, and then it's done. If we would use Docker, it would be a very similar process. So we feel quite comfortable. Of course, we are looking into it from time to time, but currently we are not heavily investing in Docker. How long does a deploy take? So from push to GitHub to a new service in production, we're currently in the realms of 20 minutes, which is mostly due to the EC2 startup times. This is the thing that takes the most time, and we could improve on that. And actually, in our data center, we were faster. When you just ship code, you can be faster, but within those 20 minutes, we actually are recreating all the servers we are running on. Okay. Yeah. Inside of a VPN. So are all our EC2 instances scattered around the internet or inside a VPN? No, we don't have a VPN from AWS to our data center, and all our EC2 instances are currently scattered around 3 availability zones in Ireland. So this is where one of the European regions, so AWS has 2 regions in Europe, Frankfurt and Ireland and has 3 availability zones in Ireland, and all our EC2 instances are scattered around the 3 availability zones. So how long does it take for 2 microservices to actually communicate to each other? I don't know. But gut feeling from all the things we are seeing around network latencies, it's 1-digit milliseconds, I would assume. So are there any optimizations? So how we cut our microservices, having those vertical slices being a business capability, we don't have that much of a cross microservice communication going on. We have a lot of communication. I will touch that when I talk about UI composition, how we compose the services together. So monitoring is the new testing. So there are 2 important things for that slide. First, when you do microservices, testing becomes less important. Why is that? Because typically your tests are run when you're delivering a service. At that point in time, it totally makes sense to test that the service is doing what you're intended to do. But when you have many services in production at the same time, a lot of other things can go wrong. So your service is happily humming along, but another service is delivered now, and the integration between those 2 services is no longer working. So therefore, your tests wouldn't catch that because you're actually not delivering. So you need to have more emphasis on monitoring. You also need to be, you need to do different kinds of monitoring. What we don't have yet is monitoring on a KPI level, so what actually are our business metrics we're interested in, but this will be one of the next things we tackle. The other very interesting part is what happens if you have those autonomous, you build it, you run it teams. Nobody told them to build a dashboard like that. No CTO came around, you need to look out for the requests per second or something like that. They just did it. They took the ownership of their services. And then they are doing things like, you can't see that the open ops genie alerts. So the team, of course, has the pager. When you build it, you run it, the team is carrying the pager. So they know how many open alerts they have. Over there, they know how many AWS costs their service had over the last day. So cost transparency, they know what their service is actually doing. And they're measuring a lot of things that they actually know their Google page speed of the service as it's right now for the different devices. And all of those things happen when you actually give a team the responsibility for those services. This is a beautiful thing to watch, that you're now actually running around and seeing, this team has something on their dashboard which we don't have. We need to switch it also on our dashboard. Who of you is using feature branches? Those of doing feature branches, who of those, keep your hands up, raised, doing feature branches are also doing continuous delivery? Trick question. So I personally believe that feature branches and continuous delivery or continuous integration, I need to say, actually don't mix and match very well. So I'd rather say, when you want to do continuous integration, please look into feature toggles. This is a trunk-based development, is a more sustainable approach for continuous integration, because you're actually continuously integrating everything. A feature branch is not integrated with the REST application, despite that there might be a Jenkins build sitting on top of it. And the important other aspect of feature toggles for us is that we are now capable of decouple a feature release from the code deployment. So who does not know what a feature toggle is? Okay, so in essence, it's an if statement in code, and you have either a configuration way or a dynamic way to enable those feature toggles to enable a feature in production. And this is tremendously helpful to decouple those things, and we will come to this a little bit later. Uh, Another thing is how actually continuous delivery pipelines work when you have more than one service that's going into production. So in this picture, if you look at the yellow service, which currently is in the staging environment in version 5, and it's integrating happily with version 2 of the blue service. Everything works, all tests are green, and now the yellow version wants to go into production. What's going to happen? He's now going to integrate with version 1 of the yellow service. Oh, so now you have built a beautiful staging environment to verify that actually your system is working together, but when you have many of those delivery pipelines, where many of those services are delivered at the same time, you will never manage to have the same versions in your staging environment then for integrating with the other service than you will meet in production. And at AutoScout, we had quite some trouble in the old times with our staging environments. We invested a lot to make it look like production, never managed to do so. It took forever to get the test screen on the staging environment, only to find out later in production that we still had some downtime or something like that. So with those two things, we now believe that we actually don't need a staging environment anymore. So what we've done is we completely skip staging. We have a dev account where we actually verified that the infrastructure automation is working and the tests and the services can be tested in isolation, and then the next step is to actually go into production. Of course, we don't want to be stupid. We are investing in still make this with confidence, meaning stuff like feature toggles. The code is in production, but the feature is still not switched on. So I can, for example, as a automated test or as a QA person or as a product owner, can enable the feature in production just for myself. So we have a Chrome plugin where you just select your feature toggle, and now I want to test feature A, how the page actually behaves if I turn it on, and I can see the result. And only then gradually, like a canary release, enable traffic to this new feature. We also do things like blue-green releases and canary releases we are attempting on a code level. And for the service version mismatch, we introduced something, a concept called consumer-driven contracts, where actually the consumer is writing the contract that the producer is obligated to run against. And in the previous picture, the yellow service in the test environment or in the dev environment can run the contract test from version 1 of the yellow service before going in production. So he actually knows that when he will meet the real service, that he is fulfilling the contract needed there. So this helps quite a lot. And I believe, yes, there's something else coming. So I make this brief because I'm at 50 minutes already. Event sourcing and data pumps. So when integrating our data center with AWS, of course, we have the Oracle database there, and there's a lot of backend processes still running in the data center, and we need the data in the cloud. So we are building data pumps, which are more or less one-way data highways that are pumping the data from our Oracle database into the cloud, into DynamoDB or into Kafka, whatever seems fit, so that it's available for the service to be consumed. And we are looking also back in the data center also for some services on AWS into event sourcing, which is also the notion that you have a constant stream of events which you are collecting. But I won't go deeper into that one. What was very inspirational in the beginning of our project, when we came up with our first data pump, this is how the whiteboard looked like, how we should do this. We were all new to AWS. We just knew we need the data in there. And of course, if I want to put data from there to there, I need a queue in between, and I need a database but we actually didn't know how to do it. And these are all attempts we tried. So in the end, we ended up with just using DynamoDB, but all the AWS services in between, we tried out how they actually work together. It took us, I believe, 2 weeks, and we had a working prototype of all of those solutions. And when I think back, what would happen in our data center if I would go to operations guy, I want to try something with a queue, please install me RabbitMQ. Of course they would do it. And then 2 days later, ditch RabbitMQ, I now need a database. No database, please install Kafka for me. They would go mad. On AWS, all of those services are just API calls. It's very easy to bootstrap them, so the evolution, the time it takes to actually try something out, and with no cost, you can actually delete a whole infrastructure and try something different again. This speeds up how you think about those services and how you actually are able to evolve there. With the advantage, you can always do also a back of the napkin calculation, how expensive this approach would be. Is it more expensive to put the data on S3, and how much more expensive it is versus DynamoDB? You can just calculate that, which you can't do in the data center. We have previously talked about the sharing already. So more or less, we believe in loosely coupled and sharing as few as possible. And this, initially we had a principle we called share nothing, which is now rephrased to loosely coupled. But the provocative notion of shared nothing also made the point very clear that developers try to share something. So I've seen developers over and over again. Now I've written 10 lines of clever code. I make a library out of that and will be famous. And of course you will not. And you couple everybody to the library, and then you have to upgrade it, and no fun anymore. And microservices are more about isolation and not about sharing. So therefore, copy and paste is actually a good option as long as you're not overdoing it. Business behavior should not share at all, because business behavior belongs to our microservices. And not being coupled to the other. So as when your library is now used by 10 people, you can't change it fast anymore, because you need to make sure that it still works for the others. Of course, there are some exceptions to the few sharing things, as we already mentioned, monitor logging. So when there are macro concerns involved, then of course you need to share stuff. But besides that, try to stay away from the urge to actually build shared libraries out of your code. So I will briefly touch the front-end integration. As I told you already, we have those vertical slices with a separate, which are capable to render their own UI. But in the end, the user of AutoScout should not know that we're actually building microservices, and that each of those teams is responsible for a different page, and that even within the page, different teams are involved. So we need to compose the whole thing back together to make one web site out of it. Nevertheless, it should still be loosely coupled, which is one of our principles. The teams should keep their autonomy while doing this, so we don't want to build a UI monolith on top of API services or something like that. This would fall back into the old times. But nevertheless, the resulting pages should have a good page speed. So we're a rather high traffic website, so rendering time, page speed time is very important to us and to our customers, so this needs to be in place. And we came up with something like that. CloudFront is the CDN from AWS, so every incoming request now hits CloudFront first. And as we are in the migration phase, most of our services, or many of our services, are still in the data center. So CloudFront will then, via policies that are in the just directly route the traffic back to our data center. But for those services that are already existing on AWS, it will hit the load balancer in front of our Jigsaw, which is, I believe we now have changed the code name because there are many Jigsaws, Java 9 and so on. But at that point in time, it was still called Jigsaw, which is more or less an Nginx cluster. And then from Nginx, it's routed to the different services. So one of those services could be the homepage service, the list page, and the details service. And we also want to compose stuff. For example, if there's a header and a footer, we have a service for the header and a service for the footer, and those need to be UI composed. And how do we do that? The yellow part is the page itself, and within this page, there is via SSI include a fragment, and what the SSI include just does, it makes another request to the blue service and returns the resulting HTML. But as we want to have autonomous teams, the team that is rendering the fragment should also be responsible for the assets of that fragment, being JavaScript or CSS. And because we don't want to couple us to a central asset pipeline, and the page itself, of course, has also CSS and JavaScript, which the page needs. And this would make up an awful web page experience if you clutter around your CSS and your JavaScript. So the magic ingredient in there is that we just use Nginx PageSpeed, which is mod PageSpeed, which is provided by Google, and is a plugin that actually optimizes your page for optimal page speed. So we are misusing this module to actually clutter our assets around the pages via fragments and not worry too much about page speed, and then just at runtime let the module run and compose it all together. So I believe I will skip the infrastructure guild today because 1 hour, I believe, is enough. Thank you very much. Any more questions? Yes. Okay.
At the end, you have something like, included 3 times.
Okay, so the question was, when we do this kind of UI integration or composition, what about if the JavaScript in there actually is jQuery 1.8 and 1.82, and then I have jQuery flying around 2 times? So answer number 1, we are using vanilla JS and only small parts. Question number 2, of course you should not be stupid. So not using those heavyweight libraries, because this jQuery, the page speed will not be that good anyway. But for other libraries. So in essence, we are using only few libraries, and we have something which we call a Shoka UI library, which is included once, and which brings with it only the core stuff needed for integrating. So for example, for the event hub for UI composition, and if there is an Ajax library, this could be part of the small UI library we actually share over all these pages, which is something we had very strong discussions about this, how we should do it, and you can ask me afterwards how we came to a solution, because this is not an easy one, because you're now sharing something over the whole website, and this has the capability to, with one release, actually turn off the whole web page or break in all different places. So this is not something we did lightly, but this is where this part is living. For everything else, we use stuff like namespacing, or in the CSS realms, then mixing and those kinds of things, that they're actually not colliding on the site itself. But there might be the case that you're actually increasing the payload, because all those little parts might be duplicated in there. Yeah. Yes?
You mentioned that you usually use Nginx and EC2.
No, only chicks. So the question was, do we use Nginx and EC2 in the backend?
The question is actually,
Different.
how do you pick up with the dynamic nature of
Okay, so from an Nginx perspective, how we deal with the auto-scaling groups.
using the ELB?
Yes, so we have an auto-scaling group with an ELB for an Nginx cluster, and normally, so for Nginx, each of those instances is actually autonomous, so it does not matter that we have many of them, and they're actually scaling. But no, we're not changing the configuration in that time. Uh, we are not changing the configuration, or if when we are changing the configuration, what's happening then? Ah, okay. Okay, so how does Nginx, ELB, and updates actually work? So for most of our services, which are then not Nginx based but Scala Play application, we are mostly doing CloudFormation rolling updates. So the new instances are staying behind the same ELB. We are not swapping out the ELB, which has all the troubles that if you recreate if you create an ELB from scratch, it will just be a small ELB, and then you either have a support ticket with AWS to bring it to proper size, or you need to manually treat it that it actually is scaling up the ELB itself. AWS first is one of our principles. This is one of those services you just insert coins and it works. So just works within the boundaries of what the service is capable. And in the example of Nginx, we actually introduced a blue-green delivery there. So actually, during the release phase, we create an Nginx cluster of the same size and attach it to the same ELB. And only if this is okay, we detach the old Nginx cluster. Yes? So what teams the? Okay. Ah, okay. So we have those uh, autonomous teams and how we actually deal with the communication of things. So of course, autonomous teams might come up with different solution to the same problem because they just didn't know that the other autonomous teams to which they have a low communication bandwidth by nature actually have done the same. So we will have some of those duplications, but what we are trying to avoid that by having a macro architecture guild where we meet once a week, where teams bring in their problems and their stories, and we also regularly try to push all the teams who are doing something new to do a show and tell afterwards. So if one team tries out a Spark cluster on EMR and fails or succeeds, then they are more or less pushed, please make a show and tell out of that the next team actually can learn from that. But this is something you need to constantly push for, because this is the trade-off of having the autonomy. You're fast within your team and you can have local decisions, but spreading the knowledge out is hard, and you won't completely succeed. You will have duplication, and if you're lucky, then you get the survival of the fittest, which is also a good thing. So if you have two solutions, the other teams pick the better one.
One last question, please.
One last question. Yes, the raising my head, please. So how many services do we have, and how big is the size of the biggest one? So services in total, so from a self-contained systems perspective, we have around 7 or 8 of those self-contained systems, but microservices, some of them are consisting of more microservices, and there are also microservices that are part of the infrastructure, I would say 20, 30-ish, and then there are a lot of Lambda functions already flying around, so we are very keen on the serverless part of things.
So thank you very much, Christian, for your talk. And before you're all heading to watch football, I guess, you can also linger around and talk to each other, like face to face. That works. And
Yeah.
and drink beer and grab something to eat. I want to thank you again for taking the time to come here. I want to thank Christian for his talk. I want to thank Immobilien Scout for hosting us, for sponsoring the drinks and the food. So thank you very much for that. And of course, we are still raffling the tickets. So if you haven't written down your name yet, now's the last chance. If no one, yeah, it's over there. If no one runs there, then, okay. And if the last person puts down the sheet of paper, then please bring me the box.